job is coming up to this cabinet. We know that before we open this door, right, whether we are going to kill power and do a live verification, or we're going to leave power on and we're going to bypass this little thing here and open it to be able to look and see if there's a trip breaker. Before we do any of that, we know, like we talked about with this particular label, we need to set up our barrier at 42 inches. Then we need to make sure we have the PPE we are going to need to be within 18 inches of an exposed conductor, right? Bare minimum this job, you open the cabinet, you have to have your 9 cal rated company shirt, right? Your 9 cal rated company issued pants. And then you're going to be rocking your rubber gloves that comes in your kits that are all rated up to 1,000 volts. And then you're going to be wearing your heavy duty leather protectors, which protects you against an arc flash, right? So you'll have those things on to even open the door. Now, if it's any higher than 1.2 cal, you're also going to end up rocking your balaclava and your face shield, okay? Again, there's OSHA and NFPA requirements. Every employer has the right to go a step above and beyond that just to play extra safe, all right? And that's absolutely what we're going to do here. So we've got our barrier set up at 42 inches. We've got the appropriate PPE that we need to be within the 18-inch boundary. And so we're just checking to see if there's a breaker trip. So we pass it up, we open it up. Well, look at that. There is a breaker trip, okay? So now, as level 1 qualified electrical workers who have successfully gone through the NFPA 70E training plan, right? You are authorized and cleared to do all those things. You are not okay to just reach in and reset a breaker. That's definitely not best practice. The breaker trip for a reason. We need to figure out why. So with that scenario at this point, you're going to escalate that to the maintenance supervisor, and they're going to start that process to see what's going on. Why is the breaker tripping? Who else do we need to get involved here? Okay. Now let's say that we open it and the breaker is not tripped. Okay. So now maybe we're at the point where we're going to take some verification of voltage, right? The presence of voltage readings. Again, as level 1, you successfully passed the NFPA 70E training plan. You are authorized to grab a meter, put it on volts, and do a verification of 400 up to 480 volts to verify the presence of voltage or the absence of if you're doing live to live. Okay, so we already called it out. We've got our barrier, so we're good there. We've got our 42-inch barrier. We did that before we opened the door. We've got on the appropriate PPE we need to be within any of the boundary, even if we're not going to be within the boundary. I mean, technically speaking, really, it's like I could probably open this cabinet and maintain 18 inches away from an exposed conductor, but we can't do that with 100% confidence, right? I don't know exactly where there's an exposed conductor when I open this panel, right? So if there's any question, well, then you're simply going to wear the PPE you would need in order to be within that boundary, just to cover all bases. And again, this particular job, right, this company, we want to do that. We want to go the extra step, the extra mile to guarantee everyone's safety, okay? So again, we've got it out, our barrier, our physical barrier up, the right PPE we need to be within the 18 inches of 1.2 cal or below for any exposed electrical conductors in here. We verified and we've seen, let's say that neither of the breakers are tripped, right? Let's just say they were good. And now we want to take a verification of voltage. We want to actually see if there's voltage coming to this breaker. Okay, so you grab your meter, you've got your PPE on, you can verify the presence of voltage, okay? Now, let's do the other scenario. Let's say that we've been tasked with shutting this entire panel down, okay, and doing a live, basically verifying that it's dead. Maybe the controls tech is going to come in here and do some work or something like that. They're going to change out a breaker for maintenance. Okay, so we shut it off. We've got our boundary up 42 inches. We've got all the PPE we need to have for 1.2 cal below to be within that 18 inches. Is it dead? No, the answer is no, right? Like, until we go in and we verify it with our approved electrical testing device, right, our Fluke meter down here, we're not going to consider it dead. We're going to consider it still alive, okay? And so what that looks like, you open the cabinet, and like, you know, we walked through the scenario earlier in the classroom, you're going to, on the downstream side of the main disconnect, do your verification, right? Face to face, face to face, face to face, then black lead to ground, right? And red here, here, and here, just to verify complete absence of voltage. You should get 0 volts on all of them. Now, we shut this, and probably one of the most important parts of verifying electric safe working condition, right, is identifying all sources of power. Step 1. Okay, so we've got power coming in this cabinet. Not on this cabinet, obviously, it's a training aid, but if we had power coming in this cabinet, it's coming in on the top side, right? So if we throw this disconnect and we visually verify it and we use our meter to make sure there's no volts, it's all well and good, and that kills power to everything downstream of this disconnect, everything in this panel, but you still have voltage present right here, right? So what's that tell you? Well, everything on this label applies to that voltage that's present there, right? So you got to respect an 18-inch boundary. You can't do anything within 18 inches of this exposed electrical conductor because that would be considered live electrical work, right? So if you had a wire that came out on this power supply, and this takes 480 and drops it down to 24 volt DC, and you just had a simple little wire that came out, well, this is clearly within 18 inches of this. There go. You cannot take your screwdriver and use it on this terminal to reseat that wire. That's electrical work, and you're within 18 inches, okay? So those are the types of things. This is why I say a lot of 7E comes down to 3 main things. 1, being able to create and understand an electric safe working condition, right? 2, being able to read and interpret correctly everything on this label. And 3, being able to correctly perform live dead live, so you know for sure something is in a complete 0 state of energy. Once you know how to read these and understand this, and you get it, it's all about the boundaries. 18 inches, or whether it's the limited approach boundary. Once you know those boundaries, now you can apply that simple knowledge to a whole lot of different scenarios, right? So, okay, we killed power here, we verified it's dead here, and there's an absence of voltage in the panel, but we still have voltage here. Okay, so we know we cannot do any work here, right, because we're within 18 inches, but could we reseat a wire down here on this relay? We could, right? 24 volt, that's that 24 volt control circuit coming from the PLC, suck it in that relay in order to suck in the contactor and allow big 480 volts to flow to the motor and turn it on. Yeah, we could reseat a wire down here because we're further than 18 inches away than our exposed conductor, and we have to respect that 18-inch boundary. So you see what I mean when I say, like, just a little bit of information. If you understand it fully, no question, like you understand how to read this label and what everything means on it, once you have that little bit of information, it can take you a long way and help you with a lot of different scenarios, whether that be doing work in the field or being a part of planning for a JHA, and even with future training opportunities, future training programs, right? So now when we get into level 2 stuff, the level 2 training plan I have, which consists of 3 different courses, right? The industrial automation and process control, motor testing, motor start circuits. We get way more in depth using this training aid and the other mobile training card I have in our lab, where you do a lot of hands-on stuff. You actually test motors, right, with a meter, and doing ohms checks and checking the windings in the motors. But then by the end of that training plan, you'll know what every component in this cabinet is, right? You'll understand. 480 comes in right on the top of this disconnect. It comes out, it distributes off to many different circuits, whether it be down here to another disconnect for an individual pump. It goes off to this power supply, which takes 480 volts AC, drops it down to 24 volts DC, which will come over here to the PLC, right, programmable logic controller, give that PLC that 24 volt DC power that it needs, and this goes off with all its different sensors in the field, all those field devices, level sensors, flow sensors, coming back, bringing that information back to the input of the PLC, right? And then the PLC is programmed with the logic to decide what to do with those inputs to energize certain outputs, and then those outputs go off and control 24 volt DC relays for motor start circuits, and you'll start learning about these relays and these circuit breakers and some of the network gear that's used, right, for having the PLCs on the network. And I mean, we dive in all that, SCADA, the whole purpose of it and what it all is. So I think what we'll do next is we'll start getting everybody up individually, one by one, and I'll give you a card like this, or maybe it'll be a little different. And what we'll do, just kind of to prep for like that final assessment, is I want you guys to take this card and then you tell me, right? This is going to be closed, and you're going to have to walk me through. I'll give you a scenario, okay? I'll give you a scenario. I'll say I need you to open this cabinet and just visually check if there's a tripped breaker, or I need you to perform a live dead live on the disconnect. I'll give you a scenario, and then you need to walk me through. You need to read every aspect of this label and say, yeah, okay, well, I'm gonna have my boundary here. I'm gonna need to wear this PPE, and I need you to be specific, right? Let me know exactly what calorie arc flash shirt you would be wearing, or shirt, how you would be wearing that shirt, right? Buttons all the way down, buttons up, shirt tucked in, whether you need a balaclava and face shield or not, what kind of face shield, right? An arc flash face shield, not a grinder face shield or a welding helmet or anything like that. All right, so I need you to be specific. Make sure you can demonstrate a complete mastery of knowledge, understanding these labels, okay? Good deal.